Hello, friends. So let's start with the next layer of the OSI model's description, that is the data link layer. The data link layer transforms the physical layer, a raw transmission facility, to a reliable link. It makes the physical layer appear error free to the upper layer, and the upper layer to the data link is the network layer. As you can see on the screen that the diagram shows the relationship of the data link layer to the network layer, the higher layer, and the physical layer, just one layer below it. So the main responsibility of the data link layer is moving the frames from one hop node to the next. Other responsibilities of the data link layer includes the following: framing. The data link layer divides the stream of bits received from the network layer into manageable data units called frames. Second function, physical addressing. If frames are to be distributed to different systems on the network, the data link layer adds a header to the frame to define the sender or receiver of the frame. If the frame is intended for a system outside the sender's network, the receiver address is the address of the device that connects the network to the next one. Flow control. If the rate at which the data are absorbed by the receiver is less than the rate at which the data are produced in the sender, the data link layer imposes a flow control mechanism to avoid the overlaying the receiver. Error control. The data link layer adds reliability to the physical layer by adding mechanisms to detect and retransmit the damaged or lost frames. It also uses a mechanism to recognize the duplicate frames. Error control is normally achieved through a trailer added to the end of the frame. Access control. When two or more devices are connected to the same link, the data link layer protocols are necessary to determine which device has control over the link at any given time. As you can see in this diagram shows hop to hop delivery, that means node to node, machine to machine delivery of the data packets. As the diagram shows, communication at the data link layer occurs between two adjacent nodes. To send the data from A to F, three partial deliveries are made. First, the data link layer at A sends a frame to the data link layer at B, a router. Second, the data link layer at B sends a new frame to the data link layer at E. And finally, the data link layer at E sends a new frame to the data link layer at F. Note that the frames that are exchanged between the three nodes have different values in the headers. The frame from A to B has B as the destination address and A as the source address. The frame from B to E has E as the destination address and B as the source address. The frame from E to F has F as the destination address and E as the source address. The values of the trailers can also be different if error checking includes the header of the frame. Now, let's move ahead with the third layer of the OSI model, that is network layer. The network layer is responsible for the source to destination delivery of a packet, possibly across the multiple network or links, whereas the data link layer oversees the delivery of the packet between the two systems on the same network or links. The network layer ensures that each packet gets from its point of origin to its final destination. If two systems are connected to the same link, there is usually no need for a network layer. However, if the two systems are attached to different network links with connecting devices between the network or links, there is often a need for the network layer to accomplish source to destination delivery. The diagram on the screen shows the relationship of the network layer to the data link and transport layers. So, the main responsibility of the network layer is the delivery of individual packets from the source host to the destination host. Other responsibilities of the network layer includes the following. The very important one is the logical addressing. The physical addressing implemented by the data link layer handles the addressing problem locally. If a packet passes the network boundary, we need another addressing system to help distinguish the source and destination systems. The network layer adds a header to the packet coming from the upper layer that, among other things, includes the logical addresses of the sender and receiver. We discuss logical addresses later in the upcoming lessons. The next very important responsibility of the network layer is routing. When independent network or links are connected to create internetworks, that is, network of networks or a large network, the connecting devices called routers or switches routes or switch the packets to their final destination. So, one of the functions of the network layer is to provide this mechanism. The diagram on the screen illustrates the end-to-end delivery by the network layer. As we can see and understand from the diagram that we need a source to destination delivery. The network layer at A sends the packet to the network layer at B. When the packet arrives at router B, the router makes a decision based on the final destination F of the packet. As we will see in upcoming lessons, router B uses its routing table to find that the next hop is router E. The network layer at B therefore sends the packet to the network layer at E. The network layer at E in turn sends the packet to the network layer at F. Going ahead with the next layer of the OSI model is the transport layer. The transport layer is responsible for process to process delivery of the entire message. A process is an application program running on a host, whereas the network layer oversees the source to destination delivery of individual packets. It does not recognize any relationship between those packets. It treats each one independently as though each piece belonged to a separate message, whether or not it does. The transport layer, on the other hand, ensures that the whole message arrives intact and in order, overseeing both error control and flow control at the source to destination level. The diagram on the screen shows the relationship of the transport layer to the network and session layers. Transport layer. The transport layer is responsible for the delivery of a message from one process to another. Other responsibilities of the transport layer includes the following: service point addressing, segmentation and reassembly, connection control, flow control, and error control. In detail, we will see all these mentioned functions in the upcoming next lesson. Thank you for watching this series of lectures on data communications and computer networks.